Okay, AP Econ students, let's do a episode of Economics Flipped. This episode, we're looking at choice, right? It's a very important topic in economics. So the first thing we want to look at is the individual's economizing problem. So we're going to look at an individual who has a limited, so let me just walk through it with you. He's got a limited income. He's going to have $18 to spend, but he wants more than the $18 can buy him. So he has unlimited wants. Okay, he has a budget line, which is the combination of the two goods using the $18. Right? There are attainable points where he can get combinations of both goods, and then there are points where he can't get certain combinations of both goods. Then we have then we have to make trade-offs. You have to give up one thing to get another thing. This is opportunity cost. What's my best alternative to getting up and coming to work this morning? To sleep. Right? So that's the opportunity cost. The opportunity cost of any of us to be in the building during this week is the sleep we're giving up, right? Then we're going to, knowing all this information, we'll make the best choice possible. And if we want, we can change the income and see how that affects the decisions we make. All right, so let's bring up the chart. We have two goods. We have brownies and we have pizza. Pizza costs $3 a slice. A brownie costs $1 for a brownie. Right? We have a budget. We have $18 that we can spend on these two goods. So the first thing we do is say, let's spend all the money on pizza. So 18 over 3 gives me 6 slices of pizza that I can buy. But it gives me 0 brownies. All right, and the same is true if I do 18 over 1, I get 18. So I can get 18 brownies but no pizza. Right? Those are the two extreme points on my graph. And then everything inside the graph, all these other points are different combinations. So I decide, you know what, I love pizza, but 6 slices is a bit too much. I'm going to have 5, and then I'm going to use the other money to buy 3 brownies. So the combination I can have is 5 slices of pizza, 3 brownies. I'm really enjoying the brownies, so I go, you know what, I'd be willing to give up another slice because I have 4 slices, right? So I'm eating 4 slices, giving up that 5th slice, no big deal, gets me another 3 brownies. So then I have 4 slices of pizza, 6 brownies. And you can see the thing, it continues to go the same way. What you'll notice is 1 slice of pizza, the opportunity cost is 3 brownies. Every time you have a slice of pizza, it's costing you 3 brownies. That's the opportunity cost. Now take it the other way. I'm not a great math student, so I like to look at it and go, well, if the opportunity cost of a slice of pizza is 3 brownies, then just reverse the 3 over 1, you get 1 over 3. The opportunity cost of 1 brownie is a third of a slice of pizza, right? So if I give up that 1 brownie, I can only get a third of a slice. If I want a full slice, I have to give up 3 brownies to get that pizza. Okay, so that's what the graph looks like. Then what I would like you to do is, seeing that you're at home, maybe take a moment to do this. Graph it. Graph that chart. You have brownies on the x-axis. You have pizza on the y-axis. All right, so if you graph that, take a moment, pause the video. All right, this is, as you turn the video back on, how many of you actually shut the video off? All right, so here's the line, right? We have our budget line, which is this blue line. I got the two extremes, 18 and 6. And then I have points on the line, which are those numbers that we looked at. Anything on the line and to the left of the line or underneath the line, these are all attainable points given the income that we have. Out here, to the right of the budget line, are unattainable. These are points we would like to have, but we can't afford with our budget. Right? So that's how we do a problem for an individual. So you have your attainable and your unattainable. All right, next thing I want to look at, because we're going to take that problem of an individual and we're going to break it down into countries. But before that, we have to look at the 4 factors of production. What are the 4 factors of production? When I say that, it's the 4 lead actors in the economy. All right? And all the time, these are the 4. First one is land. I would call it natural resources if you want. Economists like to call it land to make it confusing. Then we have labor. Then we have capital. Now, capital, you're going to go, oh yeah, money. No. Capital is not money. Capital is the tools that go into producing consumer goods and services. Okay? Then we have the entrepreneurial ability, the person who takes the initiative, makes the decisions, innovates and takes risks. So let me use all four in an example. Let's say the land, the natural resource is coffee beans. You're a barista and you're coffee pots. Some guy, look, when I was your age, I was going into the deli or the diner and picking up a cup of coffee. Right? I guess there was Dunkin' Donuts around. There was definitely not Starbucks. But some guy said, you know what, if we take those coffee beans, get a couple of workers, give them fancy names, have these machines make the coffee, we can produce Starbucks. So the guy who created Starbucks is the entrepreneurial ability of taking the other three factors and creating a consumer good. All right? Now that we know that, we're going to look at a production possibility curve, which is a graphical representation of two goods. We're going to talk about scarcity, right? Resources scarcity. The natural resources, the land, is not unlimited amounts. Same with labor. And because there's scarcity, we must make choices. All right? Each point on the curve is the maximum. So on a production possibility curve like the individual problem one we did, each point on the curve are equal to each other. One is not better than the other. All right, so we have that. Now we're going to make some assumptions when constructing a production possibility curve. We're going to assume that we're at full employment. We'll discuss what full employment means later on, but just understand that all the workers who want to work are working. Our resources, our capital, our land, our labor are all fixed. The only way you can do this is if you fix the resources. Then we have to fix technology. We can't be changing things. Right? So those are full employment, fixed resources, and fixed technology. So I like to do this example of soccer and field hockey players. Right? We're going to construct the PPC table, and then we'll do a graph from it. But first, we need to make some basic assumptions and answer some questions. So let's make the assumptions. We're going to assume the best athlete in one sport can play other sports pretty easily. I'm not saying you're going to move a soccer player who's a great soccer player and she's going to be the best field hockey player. I'm saying she's going to be a good field hockey player. All right, which means the skills are somewhat interchangeable, which isn't always the case, but for the best athlete it is. So we're going to take three soccer players. We're going to take Emma, Val, and Viv. All right, so there's the assumptions. Now we're going to assume Emma scores 40 soccer goals, Viv scores 20 soccer goals, Val scores 8 soccer goals. Right, now, both hockey and field hockey and soccer are played in the fall, so you have to make a choice. If Emma, Val, and Viv want to play soccer, they can't play field hockey. If they want to play field hockey, they can't play soccer. Right, so Coach Casey and Coach Neville can battle this out. What's the cost of playing soccer? It's the field hockey, right? What's the cost of playing field hockey? It's the soccer. So here's my chart, right? If you look at point A, the girls are all playing soccer. 40 goals from Emma, 20 goals from Viv, and 8 goals from Val. So if all the girls play soccer, we're going to have 68 goals, but 0 field hockey goals. Okay? So what happens is they decide that we should move Emma, who's the best athlete, from soccer to field hockey. Right? Coach Casey comes up, talks Coach Neville into it, and Emma moves to field hockey. Field soccer loses 40 goals, but field hockey has an additional 20 goals they did not have before. So 40 goals, 20 goals cost 40 goals, which means that every field hockey goal cost 2 soccer goals, right? We gave up 40 and we gained 20. Then we move Viv from soccer to field hockey, and she ends up we give up 20 soccer goals that she was scoring, the opportunity cost, and field hockey only picks up 5 goals now. Because, again, Viv's skills aren't as interchangeable as M is 1. Okay, now what happened? Those 5 goals cost 20 soccer goals, which means one soccer goal costs 4. So the first player, the opportunity cost was 2 goals. Now the opportunity cost is 4 goals, and then we move Val, and we lose the 8 goals, and we only pick up 1. So what ends up happening is we see that the cost, the opportunity cost of the third soccer player was 8 goals. So as we move, our opportunity cost increases. The reason for that is because the skills aren't interchangeable, right? Now, I would graph that, put soccer on the Y and field hockey on the X. I do my A, B, C. A is if all 3 girls stay with Neville, right? And then D, which it's hard to see there on the bottom, is when all the girls play for Coach Casey. We join them together, and we have a production possibility curve. You notice it's not a straight line because the opportunity cost is increasing. So the term we like to use is bowed out. We say that the curve is bowed out. Inside, everything from the line and inside, everything from the line and inside is attainable, right? So it's the law of increasing opportunity cost makes that curve concave. Inside the curve, attainable. Outside the curve is unattainable, right? How could we get to the unattainable? We would have to figure out a way to maybe change technology, which is fixed at this point, right? So something has to change that we were already holding constant, all right? If something changes, let's say the girls work more, right? They start working out more and working on their skills. Now all of a sudden the curve pushes outwards and we're getting more soccer goals and more field hockey goals. Okay? That curve being pushed outwards now means there's more attainable points. So anytime a PPC curve is pushed outwards, it is considered economic growth. Right? So that whole shaded area there now is an increase in soccer and field hockey goals because the girls have increased their training. Okay? All right. That is this lesson, which is the conclusion of chapter 1. All right, so these 2 videos cover chapter 1. All righty? All right, boys and girls, ladies and gentlemen, children of all ages. See you next time.